different types of graphs for different types of cases, like when the object was in rest, the uniform motion, accelerated motion, uniform acceleration. We also saw the difference between zero acceleration, constant acceleration, right? So now we'll be starting with our equations of motion. There are total 3 equations of motion. The first one is V equals to U plus AT, where V will be our final velocity, U will be our initial velocity, A will be our acceleration, and T will be our time period, right? So in this case, our U and V will always consider it as positive, and we all know that our T, time period, will never be negative, it will also be positive. But when it comes to acceleration, we will have 2 types of acceleration. First is our positive acceleration and another will be our negative acceleration. This positive and negative acceleration will be defined according to the given situations that we'll discuss in the further examples which we'll be discussing next. Then we have the second equation which states as S equals to UT plus half AT square, where S will be our total distance covered. S will be the total distance covered. Okay, rest U will be same as it is. U will be our initial velocity, A will be our uniform acceleration, and T will be our time period. And our third equation is V square equals to U square plus 2AS. Right? So V will be same, final velocity, U will be our initial velocity, and A will be our acceleration, and S will be the total distance covered. Okay. So whenever we are given any condition about any motion, we'll be always given 3 parameters. We will be given 3 parameters. And based on these 3 parameters, it can be our initial velocity, it can be final velocity, it can be acceleration, it can be time period or the distance covered. From any of these 3 parameters, we can find the rest 2 parameters. We can find the remaining 2 parameters. And using these 3 parameters, based on these 3 parameters, we'll have to determine which equation we are going to use. Okay, if we are given the final velocity, the initial velocity, and our acceleration, and we are supposed to calculate the time, we'll use this first equation. Okay, and even if we are supposed to calculate the distance, only if we are given final velocity, initial velocity, and acceleration, we can also use this third equation, as there is also the final velocity, initial velocity, and acceleration, and from here we can calculate the value of our total distance, right? So in this way we'll use the equations. There are some examples which we'll discuss now. Okay, so see, the first example is example 1. A car starts from rest. A car starts from rest and accelerates uniformly at 4 meters per second square for 6 seconds. Find the velocity of the car and the distance it covers during this time. So here it starts from rest. So as it starts from rest, our initial velocity U will be equals to 0 meters per second, right? It will be equals to 0, and it accelerates uniformly. See here the value of A. Here it is our uniform acceleration, and it is also given here that it accelerates uniformly, right? So our value of A will be equals to 4 meters per second square, and it is equally important to write the units correct. Okay, so our initial velocity is always in meters per second, Our acceleration is always in meters per second square, and our time period t is given here as 6 seconds. See here, it is a 6 second. Now first we are what we are supposed to find? We are supposed to find the velocity of the car. The final velocity of the car. What will be the final velocity? And for that we have u, we have our a, and we have our time period t. So using these three, if we check these three equations, we are having, if we go to this first equation, we are having u, we are having a, and we are having t. So using these three, we can calculate the value of v. So we'll check how to calculate the value of v now. So we have the equation v equals to u plus a t, and our u is equals to 0. Our value of a is 4 meters per second square. So it will be 4 multiplied by t. What is the value of t? T is equals to 6 seconds. So 4 multiplied by 6. So our value of v will be equals to 4 6 24 plus 0. It will be equals to 24 meters per second. Okay. So from here we got the final velocity of the car, and we are also supposed to find the distance it covers during this time. Our time is 6 seconds. So our second equation. So for that purpose, now we have u, we have a, we have time period t, and we have the value of v. So if we go here, now we can use the second equation. See, we are supposed to find the value of s. We see the second equation, we are supposed to find the value of s, the total distance covered. Now we have u, we have the value of t, we have the value of a, and also this t, and we can make the square, right? So now we have the equation as s equals to ut plus half at square, and our u is equals to 0, t is our 6, plus half multiplied by the value of a is 4. So half multiplied by 4, and our t is 6, and 6 square is 36. Can write it this way also. Okay. So 0 multiplied by 6 is equals to 0, and now we can cancel out this 2 with this 4 as 2 times. So we'll get 6 into 6 as 36, and 6 to the 36 to the as 72, and this 72 plus 0 is equals to 72, and from this we get our s is equals to 72 meters. So in this way we use the equations of the motion to solve the problems on the motion. Okay. So now we'll move on to our next question. Now see, a train is traveling at a speed of 90 kilometers per hour. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meters per second square. Now see, we here are getting now a negative acceleration, and we are supposed to find how far it will go. Means we are supposed to find a distance before it stops. Before it stops. The word stops plays here the important role. So we are given our initial velocity. It is initially traveling with a speed of 90 kilometers per hour. So our u is equals to 90 kilometer per hour, and our acceleration A is equals to minus 0.5 meters per second square. But now here we are only given the two values. What about the third one? It will come from this statement. How far the train will go before it stops. As it is stopping, we are getting the final velocity as equals to 0, because when an object will stop, its velocity will be equals to 0 meters per second, right? And here you can see that our u, it is in kilometers per hour, and our acceleration is in meters per second square. So our first step here will be to convert this kilometers per hour into meters per second. So to do this, to convert kilometers per hour into meters per second, we have one formula that we will multiply this 90 kilometer per hour with 5 upon 18. If we multiply the speed in kilometers per hour by 5 by 18, the resultant will be our velocity in meters per second. Okay. So to convert this kilometer per hour into meters per second, what we do, we multiply by 5 by 18, and after performing this calculation, we'll cancel this 18 with 90 by 5 times, and this 5 times 5 will be equals to 25 meters per second. Now we have the value of u. This will be our u. We have the value of a, that is minus 0.5 meters per second square. We have the value of v, and now we are supposed to calculate the value of s, that how far it will go before it stops. So if we check the third equation, which says that v square equals to u square plus 2a s. From here, we have the value of v, we have the value of u, we have the value of a, and we are supposed to calculate the value of s. So substituting these values in this equation, we get v square, v is 0. So 0 square is equals to 0. Or u is this updated value, this new value, which is in meters per second. So this value is 25 square, and our plus 2 times, wait, we know that our acceleration is negative, so this plus sign will now be converted into minus 2 times. Minus 2 times, what is the value of our acceleration? It is 0.5 into our displacement or the distance, which is s. So that will be equals to 25 square is 625 minus this 2 times 0.5 will be equals to 1, and this 1 times s, and this is equals to our 0. This is 1 times s. So from here we get the value of s as equals to 625 meters. By simplifying this equation, we get the value of our s as 625 meters. So the train will travel 625 meters before it stops. Okay. So if you are supposed to calculate this in kilometers, so what you will do, you will simply divide this 625 by 1000. So if we divide this 625 meters by 1000, we will get answer as 0.625 kilometers. Okay, so we have calculated the answer in meters as well as in kilometers. So now we'll move on to our next question. It says that an object is thrown vertically upwards with a velocity of 30 meters per second. What will be the maximum height what will be the maximum height it will reach before coming down on the ground. Also find the time period of this complete journey. Now see what is happening. We are standing on the ground. An object is thrown vertically upwards. It goes to some height, and then after reaching that height, it again comes back to the ground. And while throwing this object vertically upwards, we have given the velocity. This velocity will be our initial velocity. This is given as 30 meters per second. This velocity is 30 meters per second, and we are only given this value that it is thrown vertically upwards with a velocity of 30 meters per second. What about the other values? Here there is nothing, right? So how we'll get the other values? Now see, when it will reach the maximum height, that will be the final point of our motion, and the vertical motion when it is going upwards, and after reaching the maximum height it will start coming down, right? As it is reaching the maximum height, when it will reach here the maximum height, its velocity will be equals to 0, because of which it will stop at this point and then start coming down on the ground. If it was having some or the other velocity, it will continue its motion upwards, and as it stops at this maximum height, it means that its final velocity is equals to 0. So from this observation, we write our final velocity v as equals to 0 meters per second. But still, we are only having the two values, that is u and v. What about the third value? And we are supposed to calculate the time period also. So how we'll get the third value and what will it be? So our third value will be the value of a. The value of a is the value of our gravitational pull. The value of gravitational pull, that is 10 meters per second square. Okay, you are supposed to remember this value whenever there will be acceleration due to the gravity. Whenever we'll get an acceleration due to gravity, whenever the object will be thrown vertically upwards or it is dropped from certain height, we'll always consider the value of g as 9.8, or we can also approximate it to 10 meters per second square. Okay, and as the motion is going against the gravity, our gravity is pulling us towards the earth, and we are trying to throw the object away from the earth. So whenever there will be such case where the gravity is pulling you in the other side of the motion, we'll consider the value of this acceleration as negative. So our value of a will be minus 10 meters per second square. So even if we are given only one value in the question, we can make out or these two values by observation, and we are supposed to know these values, that the final velocity will be equals to 0 and our acceleration will be minus 10 meters per second square. Okay, so from here we'll use the third equation. Our third equation is v square is equals to u square plus 2a s, and from here we know that the value of v is 0. So 0 square is 0. Then our u square means our 30 square. 30 square is 900. And as our acceleration is negative, see, we have written minus 10 meters per second square, as our motion is against the gravitational pull. So it will be minus 2 times the value of gravity, that is 10. We are supposed to find the maximum height. So maximum height is represented using the letter S. Right? So that will be finally equals to, if we move this 2 times 10 to our left hand side, it will be equals to 2 into 10, that is 20 times of S, is equals to 900, and from here our S will be equals to 900 upon 20, and that is equals to, this 0 will get cancelled with this 0 of 20, and 90 upon 2 is equals to 45 meters. Always remember the unit. As we are calculating the distance is always given in meters. Okay, and then we are also supposed to find the time period of this complete journey. So first we'll calculate the time period it will require to move vertically up and to reach the maximum height. So over here our v is equals to 0, u is 30, and a is minus 10. So we'll use the first equation. Our first equation is v equals to u plus 80, or v is equals to 0, or u is 30, and our a is minus 10. So minus 10 times t. And from this, after simplifying this, we get the value of t as 3 seconds. So we get the value of t, that is time period to reach the maximum height, is equals to 3 seconds. Okay. So now as we have reached the maximum height, when we'll reach the maximum height, or v will be equals to 0, u will be, our initial velocity was 3. But as we have reached the maximum height, now our free fall will begin. Our free fall will begin from the same height of this 45 meters. We have already calculated that we are at the height of 45 meters, and from that height of 45 meters, our free fall will start. And in that case, our initial velocity u will be equals to 0 meters per second, and as our motion is along the pull of gravity, our a will be equals to 10 meters per second square. Now in this case it will not be negative, as the motion is with the pull of gravity and not against the pull of gravity. And our height s, we know that our s is equals to 45 meters, and our s is equals to 45 meters. Now again using the third equation of motion, let me make some space. Okay, so now we'll again use the third equation of motion, which is v square equals to u square, v square equals to u square plus 2as. So from here we will calculate the final velocity v square, that will be u is our 0 plus 2 times our a is 10, and our s is equals to 45 into 45. So now our v will be equals to under root the product of these three terms. So 2 times 10 is 20, and 20 multiplied by 45 is 900. So v will be equals to under root of 900, and this is equals to 30 meters per second. From here we got the value of v, and we know that our first equation v is equals to u plus 80. Now we have got the value of v, that is 30. We know the value of u, that is 0 meters per second, will be 0 plus the value of a is 10, and now we need to calculate the value of t. By simplifying this equation, we get the value of t as 3 seconds. So it took 3 seconds to reach the ground after reaching the highest point, and to reach the highest point it also required 3 seconds. Means the time required to reach the maximum height is equals to the time required to come to the ground back from that maximum height. These both are equal. What I'm saying, the time required to reach the maximum height is equal to the time to reach the ground after reaching that maximum height. Means यहाँ से अगर कोई चीज ऊपर जाती है, किसी 3 सेकेंड्स में अगर वो चीज नीचे से फेंकने पर उसकी मैक्सिमम हाइट पे जाती है, तो मैक्सिमम हाइट से नीचे लौटने में भी उसे उतना ही समय लगेगा। देखा आपने, यहाँ पे भी 3 सेकंड लगे थे ग्राउंड से मैक्सिमम हाइट पे पहुंचने के लिए, और उस मैक्सिमम हाइट से नीचे आने के लिए भी उसे 3 सेकंड का ही समय लगा है। सो our total time period of this journey is 3 seconds plus 3 seconds, that equals to 6 seconds. So our total time period of the journey was 6 seconds. So instead of calculating this again, which we have calculated in this box, you will simply say that the time required to reach the maximum height is equals to the time required to reach the ground from the maximum height, and from that we get the time as 3 seconds again. So you will never do this again. You will simply say that the time to reach the maximum height is equal to the time reached to the ground from that maximum height. Okay, you will never calculate this again. It was, I did this to just to show you that this both the times are equal. Okay, I hope these 3 examples are clear to you. So with this, our motion chapter is completed. We have discussed about all types of concepts related to the motion. We have also discussed the equations of motion now, and with this, our motion chapter will end, and we'll start with our next chapter, that is forces and laws of motion. This will be our chapter number 2, that is forces and laws of motion. So in this chapter, we'll first discuss about what is force. First of all, now what is force? You can see here any action which causes pull or push on a body. Any action which will cause pull or push on a body, it's called as force. Force is simply an action of pull or push which will act on a body. Either the action will be a pulling action or it will be a pushing action. These both two actions will be called as a force. Okay. So whenever a body is pulled or pushed, there are certain effects seen on the body. The first effect is the force can move a stationary body. See, these two people in this example, they are pushing certain car. They are pushing a car. When the car is at rest and these people will try to push it, it will come in motion. They are pushing, and we have seen that an action which causes pull or push means as they are pushing it, they are applying some force with their hands. Over here, see this, they will push with their hands to this car, and with this action of push, the car will move forward. Means as it was in the rest, it will come in motion. Similarly, it can also stop a moving body. A force can move a body as well as it can also stop the body. When it will move the body when the force is in the same direction as that of the motion in which we want. Means if we want a car to move in this direction from left to right, and we are also pushing it in the same direction. So this will make the body, stationary body, move. But if a body is moving from say right to left, and we are applying some force from left to right, in this case the moving body will come to rest. Okay. So the third change, we can also change the speed of a body in motion. If there is any body which is in already in motion, say if you are riding a cycle, when you are on the slope, you don't pedal the cycle, right? You just simply sit on it and let the cycle move on its own whenever you are on the slope. But if you start pedaling, means you push the pedal, right? If you are pushing, means you are applying some force, and because of this force, whenever you pedal the cycle on a slope, your speed starts increasing. Means whenever you will pedal, whenever you will apply force on your pedal, the speed of the cycle will increase, right? So we can also change the speed of the body in motion. We can also change the shape and size. See, we can also change the shape and size. You can see these examples in this photo. See, these two arms are trying to press this spring, and this shape and size of the spring will change. See, there is also one sponge which is being pressed with the hands, because of which there is change in its shape and size. See, there is also one can. When the can is pressed, it will change its shape. So force can also change the shape and size of the object. And now the fifth and the last change is the change in the direction of the motion. Now see, now there is IPL going on, and many of you must also be watching the IPL. So whenever a bowler throws a ball towards the batsman moves its bat and plays a shot, right? Suppose a bowler throws a ball towards the batsman like this, and the batsman uses his bat. The batsman uses his bat to play the shot, and with this, the ball was first traveling in this direction, and now as the batsman plays the shot, the direction of the ball is now changed, right? When the ball was first moving from left to right, and as the batsman plays the shot, the direction of the ball will now be changed. It will now be from say right to left. So in this way, because of the force, we can see there is a change in the direction of the motion. Now we have seen that a pull or push is called as force. We have seen the effects of the force, but how we'll calculate the value of the force? See, for that purpose, we have one formula that force is equals to mass into acceleration. Whenever we multiply mass with acceleration, we'll get the value of force. Make sure that you write this formula in your notes, as it is very important formula. And this force is a vector quantity. Vector quantity means it will have magnitude as well as direction. Right? See over here, when the people were pushing the car, they are pushing in some certain direction, right? So the force will always have magnitude as well as a direction. And the SI unit of force is Newton. Means the Newton will force will be measured in Newton. Like the mass is measured in kg, so force will be measured in Newton. See, and 1 Newton of force is equals to 1 kg meters per second square. Now, what does this mean? We have seen that the formula for force is mass into acceleration, and 1 kg of mass, when 1 kg of mass is accelerated with the value of, when 1 kg of mass is accelerated with the value of 1 meters per second square, when it is accelerated with the value of 1 meters per second square, will get a force of 1 Newton. Will get a force of 1 Newton, and this is what written over here, that 1 Newton is equals to 1 kg meters per second square. Okay, and different examples when the force is applied, they are given over here, that kicking a ball. Whenever a footballer kicks a ball, he applies some force on the ball, and because of which the ball which is at rest comes into motion. Then also lifting a box from floor. When the box is kept at is on the floor, it is always on the rest, and whenever you will try to lift the box, you will need some force, and because of this force the box will come into motion. There is again one more example that says that stretching a rubber band. Stretching a rubber band. To stretch a rubber band, you will also need some force, and because of this force there will be change in the shape and size of the band, right? So these were the examples of force along with the effects which I have discussed. And now we will be discussing the balanced and unbalanced type of force. What are the balanced and unbalanced forces? So first it is the balanced force. Now what is a balanced force? When the net effect produced by number of forces acting on the body is 0. When the net effect acting on the body is 0. When equal and opposite forces are acting. So for example, one force is acting from left to right of say 2 Newton, and another force of 2 Newton is acting in the completely opposite direction. So this will be considered as balanced force, as they will cancel out each other. This 2 Newton will cancel